For centuries, we believed that time was a river flowing steadily and uniformly throughout the universe. Every moment was synchronized, every clock ticking in unison. This was the Newtonian universe, orderly and predictable. Then came Albert Einstein. His theory of relativity shattered this comfortable notion of absolute time. Einstein showed us that time is not a rigid framework, but a flexible fabric woven together with space. This fabric, space-time, can be stretched and warped by gravity. Imagine a vast sheet of rubber stretched taut. Now place a bowling ball in the center. The sheet curves around the ball, just as space-time curves around massive objects like stars and planets. This curvature affects the passage of time. Time slows down in stronger gravitational fields. This is not a mere theoretical concept. It's a measurable phenomenon. Atomic clocks, incredibly precise timekeepers, tick slightly slower at sea level than they do on a mountaintop where gravity is weaker. This difference is tiny, but it confirms Einstein's revolutionary idea. Time is not absolute, but relative. It flows at different rates depending on where you are and how fast you're moving. This revelation has profound implications for our understanding of the universe. It suggests a cosmos far stranger and more wondrous than we ever imagined. To grasp the full impact of Einstein's insights, we must abandon our earthbound intuition. We tend to think of space and time as separate entities. Space is the vast emptiness around us, while time marches forward, never slowing down. However, relativity tells us that space and time are inextricably linked. They are two sides of the same coin. Space-time. Space-time is the very fabric of the universe, the stage upon which the cosmic drama unfolds. It is not a static background, but a dynamic entity. Massive objects warp and distort space-time, much like bowling balls on our rubber sheet. This warping is what we experience as gravity. Imagine two objects placed on the rubber sheet. They will naturally roll towards each other, following the curvature created by their combined mass. This is analogous to how gravity works in the universe. It is not a mysterious force acting at a distance, but a consequence of the curvature of space-time. This understanding revolutionized our view of the cosmos. It opened up new avenues of exploration, leading to mind-bending concepts like black holes and the expansion of the universe. The idea of an eternal and infinite universe is not new. It has been pondered by philosophers and scientists for centuries. However, Einstein's theory of relativity provided a new framework for understanding this concept. If time is not absolute, then there is no single now that applies to the entire universe. Every point in space-time has its own local time. Imagine a vast cosmic tapestry woven from countless threads of time. Each thread represents the timeline of a particular location in the universe. These threads are interwoven, connected by the speed of light, which is the ultimate speed limit in the cosmos. In this tapestry, there is no beginning and no end, no single moment that defines the entire universe. The past, present, and future all exist simultaneously, but our perception is limited to our particular thread of time. The concept of an eternal universe has profound implications. If the universe is infinite and has always existed, then every possible event, every conceivable configuration of matter and energy must have occurred at some point. In fact, these events must have occurred an infinite number of times. Imagine a deck of cards being shuffled infinitely. Eventually, every possible combination of cards will occur, not just once, but an infinite number of times. The same principle applies to an eternal universe. Every arrangement of particles, every star, every planet, and even every living being must have existed before and will exist again. This might seem like a fantastical notion, but it is a logical consequence of an eternal and infinite cosmos. It suggests that we are not unique, not in the grand scheme of things. We are but one iteration in an endless cycle of existence. While the idea of an eternal universe might seem strange and unsettling, there is a certain comfort to be found in the unchanging nature of physical laws. Throughout the vast expanse of space-time, from the smallest subatomic particles to the largest galaxy clusters, the same fundamental laws of physics apply. Gravity, electromagnetism, and the strong and weak nuclear forces. These fundamental forces govern the interactions of matter and energy throughout the universe. They are the invisible threads that hold the cosmic tapestry together. These laws are constant, unchanging, and universal. They are the same today as they were billions of years ago and will be billions of years in the future. This consistency provides a sense of order and predictability in a universe that can often seem chaotic and unpredictable. It suggests that even though the universe is constantly evolving and changing, there are underlying principles that remain constant.